Hi everyone, my name is Charles Austin and today I'll be discussing my final project which concerns the California condor population of Southern California and possible human influences on their livelihood. I will discuss the methods I used to acquire the data, and I'll also discuss figures found outside of the ArcGIS portal that help me explain the impacts of humans on condors. As I said before, I'm going to be focusing on the human influences to condors. However, I'll only be talking about infrastructure such as roads and waterways and what role they play in helping either boost or take away from the California condor population. And my research question is essentially, are human infrastructure directly impacting the California condor population? Um, by the end of this project, I hope to have a much better answer to that question, although I suspect humans play a major role in the population of California condors, whether it's through producing roadkill, through traffic and things like that, or causing condor deaths, you know, by that same medium. I'd like to just provide a little bit of background concerning the history of the California condor. They were critically endangered um, early in the 20th century. They're one classification behind being extinct in the wild, so definitely a problem that needs to be addressed. The populations decline mostly because of poaching, the habitat destruction, from logging and things like that, and also lead poisoning since condors scavenge a lot, and different fish such as carrion, may contain lead shots. In the 1980s, fewer than 2 dozen condors were left in the world, but conservationists rescued the remaining condors and began breeding them in captivity. Now there are roughly 300 condors in the wild and 500 total in the world, which is very impressive. Now here's a figure that shows the known causes of mortality in the wild for condors in about a 27-year span. As you can see, the biggest reason with half, of the pie chart is going to be lead poisoning. As I said before, condors are predominantly scavengers, and anything that they scavenge from, they're going to take on whatever is in that host. So that could be disease, and it could be you know, things like lead. And you also see things like trauma, which would go under, vehicle collisions and things like that. That'll go under trauma. So, um, although roads aren't necessarily a big part in it, I will say that the waterways can be, and that the lead is in the fish and it's impacting the condors themselves. Now, here's a California condor population trend chart. As you can see, the condor has been increasing steadily since 2010 in the overall total population, although the wild population and the captive population tend to fluctuate for their own reasons. But they always seem to fluctuate proportionally, which tells me that those released captive condors are being released into the wild, and some of the wild ones are being taken back in. So that's what that would tell me. A fluctuation in the number of condor for wild and captive does not necessarily correlate with death. As I said before, it seems to be directly proportional to each other, which would tell me that, you know, one goes in, another goes out, one goes out, another goes in. So here's my study area. I'm very close to Los Angeles. I'm about 30 miles from Los Angeles in terms of my study area. So there's definitely going to be some heavy traffic. Um, you can see it kind of down here in the Landsat image. You can also kind of see it down here in the Google Earth image. And both of these images, provide me with different things, but they're both very helpful when trying to figure out what exactly are the causes for this, the condor population change. As you can see, there are a lot of, roadways, and there seems to be a metropolitan area down here. So that can definitely be an area where condors get their food or also sustain injuries. So here's another view of my study area. As you can see, I've got the California condor final critical habitat in that area, highlighted in the yellow and pink boxes. And then I've also got two different layers on this map. I've got a California hydro layer, which is blue, the blue streams, and that's just showing the different major waterways that are in California. And then I've also got California roadways, which show a lot of the major roadways that lead throughout California. And what I'm hoping to show with that is that the California condor habitats tend to be close to these different human hubs. And that's because they're primarily scavengers, and that's how they would find their food. So this is just another view of the final critical habitat for the condor, with a land cover layer on it, just to illustrate, what predominantly is the landform in that area. Um, that should help you understand um, the behaviors and characteristics of condors, which will tell you where to find them and where they find their food and things like that. So essentially, right here, I have my critical study area of the condor, which is going to be this box right here. And this box is actually a 10 class isometric classification, which is showing me what different land formations and what type of vegetation is in that area. And then you've got the pink boxes, which is the actual condor habitat. And then down here, you've got a nice heat index visual, which shows the concentration, the density of roadkill in this area, actually. So the darker it is, the more dense the roadkill is. So wherever you see red, that's going to be the highest roadkill levels, and wherever you see blue, that's going to be the lowest. And it makes sense that the closer you get to major cities, the darker the color gets. So you're more likely to find condors in those areas, whether it's 10 miles or 20 miles from their nesting area. They'll be somewhere in that area. So I've got these three maps that should aid in visualizing, just how much roadkill there is in California and where the roadkill tends to be and what type of roadkill there is. So it's classified as large roadkill as well as deer incidences. So the thing about that is there will be deer incidences in the large roadkill category. So you have to keep that in mind. Uh, Condors don't eat only deer roadkill. So it would make sense that they only are a small portion of the large roadkill. So the legend to the left shows incidences of accidents per year in that area. You know, blue is 0, and as you get towards red, that's how more often it happens in that area. So as you can see, certain areas where there are, high roadkill counts, there are also red areas on the road, which show that that's actually where, humans have accidents. So here I have Landsat images as well as 5-class ISO images of my study area. This Landsat image, the first one was taken in the early 2000s, while this Landsat image was taken, earlier this month. So the ISOs are going to show different things. As you can see here, there seems to be less dark green in this map, um, which tells me that it's not picking up the deep forest vegetation that it does on this map. And that can be because, a few different reasons. It could be because that actual habitat has begun to flourish over time, or it could also have something to do with the resolution of the, first Landsat image. Not quite sure, but it can definitely be either one of those. So in terms of the method, it was very straightforward. You find relevant data that has to do with your topic. We prepare the data, and then we have to do, analysis of the data. And I'll break down each step and what I did within each one of those steps. But I did that for, each set of data that I would look for and find. So in terms of finding relevant data, most of my data came from the ArcGIS All portal. I had a lot of problems with finding relevant data online that was also that would also work for my project within ArcGIS. So I had a lot of problems with that, and I just figure I need more practice with finding that information. So in the meantime, the All portal was perfect for helping me find all the information I needed. And as you can see down here, I've got 7 different, layers for this project. So I've got the California condor final critical habitat, which just lays out where in Southern California is where condors tend to be mostly. Then I've got the U.S. land cover map, which shows the different vegetation in that area. I've got the U.S. state boundaries map, which just really helps me distinguish California's border only. That's really all I used it for. I also found a roadkill density layer for the Los Angeles area, which I thought was very, very helpful because it helped add legitimacy to the claim that, the more roadkill there tend to be more condors. They have a direct influence on each other. Also added the major roadways within California. Um, this is going to highlight all the major roadways that help get traffic through California and things like that. Um, it does not give you many minor roads because that'd honestly be too many and it wouldn't load. It'd probably take forever to load. So I just went with major roadways because uh, that's simple. That should be simple enough to illustrate the idea that condors tend to be around major roadways. I also added California Hydro, which is just the hydrography of California. So major lakes, streams, ponds, things like that. I added those because, you know, California condors, they don't only eat, mammals, they'll eat fish. They'll scavenge for fish too. And that's one of the major ways that they actually hurt themselves through lead poisoning in fish. So I had to add the California hydrography layer because it just makes sense. I also added the California State Highway layer, which helps illustrate the density of traffic within those areas of the highway. So, in terms of finding relevant data, there were a few other places that I went to look. For the purpose of showing the change over time of my study area, I went to the USGS Landsat Look Viewer website and I downloaded Landsat 7 and Landsat 8 imagery. And they were about 2 decades apart. So they definitely showed significant change in the vegetation in that area. I also utilized Google Earth to get Google Earth pictures of the study area, which have their own pluses. Um, and I also went on a number of websites to get the data sets themselves. So, United States National Park Service, the Forest Service, they have a great variety of data, um, and it's easily accessible. So those are really awesome websites. So the next step was to prepare the data, and all I did for that was projected all of the data into the same coordinate system, and then clipped all of the data into the same raster extent. And what that does is just clean up all the data that you have gotten, and it helps you weed out things that you need and don't need. So after I prepared the data, I did a data analysis. So I used various techniques to help visualize this change within my study area. So different geoprocessing tools such as hillshade, aspect, slope, the ISO cluster, which was very helpful in showing you what exactly each pixel represents, whether it's vegetation or bare ground or water, things like that. That's very, very helpful, and I really appreciated working with that. So, in conclusion, I think it's obvious that human infrastructure plays a vital role in the livelihood of California condors. I believe maybe that targeted legislation is needed to ensure that the condors and their habitats remain resilient. In terms of the research question, now I'd have to say yes and no. Simply because we can't prove that those are the only reasons.